everyone, I'm Soyoung Kang from KAIST. Today I'd like to present our work, Streamlined Facial Data Collection based on utterance and emotional data for human to avatar reconstruction. Here's the table of contents for today's presentation. So we'll start with some background and motivation for our study, then research objectives and key questions. Next, study 1 on facial data acquisition and performance evaluation, followed by study 2 on user evaluation. Finally, we'll discuss the results and conclude with key takeaways. First, our research focused on how we reconstruct avatar face, especially in terms of human to avatar facial expression. Nowadays, there is a growing demand for realistic and expressive avatars, especially in telepresence scenarios where subtle facial cues are essential for authentic interaction. However, current methods for creating such avatar require large data sets, which makes them computationally expensive and impractical for everyday users. Also, even if avatars score well on technical metrics like accuracy or similarity, they don't always guarantee a comfortable and natural user experience. An avatar can score perfect but still feel uncanny or reduce immersion. Our study addressed this gap by asking what is the minimal yet sufficient facial data needed for engaging conversational avatars. So here we focus on two types of facial data: utterance data, which captures speech-related facial movements, and emotional data, which captures emotional cues. So instead of assuming that more data is always better, we explore a streamlined data collection approach aiming to build effective and engaging conversation avatar. Therefore, our research has three main objectives. First, we aim to identify which facial data are truly essential for reconstructing avatar. Second, we compare different types of data collection methods to understand how each contributes to the quality. Lastly, beyond technical performance, we evaluate how these data collection methods influence user perceptions. So to address this, our research focused on three key research questions. And to answer these questions, we designed a two-phase study. And in the first phase, we evaluated different types of utterance and emotional data to identify the most efficient combination. And in phase 2, we validated our findings with users by comparing three conditions. So here we compared three conditions based on the best methods from phase 1. Now let's dive into the data collection one by one. First, utterance data captures facial movements that occur during speaking, driven by coordinated articulation. For utterance data acquisition, we tested three methods. First, participants articulated key Korean consonants and vowels, testing whether a minimal set of core articulations could produce realistic avatars. Second, participants read pre-written news scripts to capture structured speech patterns. Lastly, participants delivered unscripted free topic speeches, capturing dynamic and naturally varying expression. All three methods included baseline recordings of head and eye movements to capture essential cues. Second, to complement the utterance data, we collected emotional expressions. So here we tested two methods. First, direct emotional expression. Here, participants expressed basic emotions guided by reference images shown in the left. And emotion-based facts. Here, participants followed the movements with facts that are related to emotions, following animation guides to capture subtle muscle movements. Now, let me briefly describe our experimental setup. So for data acquisition, we used Azure Connect, recording RGB video at 4K resolution. And for reconstruction, we used Point Avatar Framework, a NeuroPoint Cloud pipeline. And this approach first reconstructs the facial geometry using NeuroPoint Clouds, then maps them to a Flame parametric face model, and then integrate it into Unity for evaluation. And for evaluation, We used mean absolute error, which captures pixel level accuracy, and PSNR measures image clarity, and structure similarity index reflects how the image structure is well preserved. Lastly, learned perceptual image patch similarity assess perceptual similarity based on the feature representation. We also measured computational cost to understand efficiency, so training time, acquisition time, and data volume. For experiment 1, we focused on utterance data, testing 3 different methods. So in experiment 2, we combined the utterance methods with emotional data, creating 6 conditions in total. So for both experiments, we have 4 participants consisting of 2 males and 2 females. For experiment 1, the results show that spontaneous speech consistently outperformed the other methods. It achieved the lowest reconstruction error, highest image quality, best structural alignment, and lowest perceptual error. Pairwise tests also confirmed that U3 significantly outperformed U1, while differences with U2 were positive but not statistically significant. And here in experiment 2, we compare 6 conditions, the combination of utterance and emotional data. Here, U3E1, which combines spontaneous speech with direct emotional expression, showed the lowest reconstruction error, highest PSNR, and structure similarity, and strongest perceptual similarity. Also, to compare the efficiency of the best conditions from prior experiment, we had comprehensive experiment. And here we measured computational and data efficiency for 3 conditions: utterance only, utterance and emotion, and extensive data that includes all conditions. Here, condition 1 and condition 2 are significantly more efficient than condition 3. Next, we will overview the study 2 user evaluation, investigating how these 3 methods affect user perceptions during conversational interactions. So here we focused on 4 key aspects of user experience: realism, naturalness, synchrony of communication cues, and telepresence. This allowed us to evaluate whether avatars created from more streamlined data could be perceived as equally engaging and realistic compared to those generated from extensive data. Here we used a within subject design where each participant experienced all 3 avatar conditions. We recorded 24 participants and all self-identified as Asian to match the demographic of the reconstructed avatar. User study was conducted in an immersive environment using a large wall display to ensure consistent visual quality and minimize hardware variability. And the avatar was at life-size scale, positioned 2 meters from participants. And this is the overview of the procedure of our study. So introduction, interaction with 6 sessions, so male and female avatar with 3 different conditions, and rated after each session, so total 6 times. Now we will share the key results from user evaluation. We first analyzed participants' ratings using a Friedman's test, which revealed no significant difference across the 3 conditions. However, a lack of significant difference does not prove equivalence. So we perform equivalence testing using the TOAST procedure, and the analysis revealed that C2, the utterance and emotion condition, was statistically equivalent to C3, the extensive data condition, across realism, naturalness, and telepresence. This shows that reducing data and computational cost does not negatively impact user perception, supporting the idea that a targeted, efficient data collection can achieve a comparable quality with larger data sets. So to wrap up, I'd like to highlight the key implications from our study. So first, combining utterance and emotional data, specifically spontaneous speech with direct emotion, produce the best reconstruction results. Second, from a user perspective, an avatar generated with U3 and E1 were perceived as equally realistic and natural as the more data-intensive condition. Finally, our approach enables efficient data acquisition. So this demonstrates that a practical strategy for reducing time and cost without compromising avatar quality. So to conclude, our study demonstrates that by focusing on essential data inputs, specifically utterance and emotional expression, we can generate realistic avatars while significantly reducing the amount of data required. Thank you all for your attention, and I'm happy to take any questions you may have. Thank you.